All right, so we're going to talk about half-life. Now, half-life is the time required for half of the radioactive substances or radioactive atoms to undergo decay. So imagine, we'll use this first example here. Imagine that you had 100 grams of helium-6. It would take 0.802 seconds for that 100-gram sample to decay so that you only have 50 grams left. And if you look at this list, some half-lives, the amount of time it takes for half of the sample to undergo decay and to become something else, the time it varies quite a bit. You have some on the time frame of seconds all the way up to millions of years. And no two radioactive isotopes decay at the same rate. Half-life is very specific to a certain nuclide. So if you look at all these different isotopes, just look at the 3 for uranium listed right here. Look at how different those isotopes or those half-lives are. So what we're going to do is we're going to go through a few examples now of how to answer questions that deal with half-life. And what you need to keep in mind is that you always start with the full amount. Pretend that the timer has not started ticking yet. Nothing is decayed yet. Everything is intact. You have all unhappy, unstable atoms that are going to decay. We just don't know when each individual atom is going to decay. But we do know, if we look at the stats, by the end of that first half-life, by the end of this first time period, it's 0.8 seconds if it's helium, it's 5,730 years if it's carbon-14, and so forth. By the end of that first half-life, you have about half of that sample remaining. And then after the second half-life passes, you have about a quarter, and it keeps going on and on and on. So we're going to take a look at the first half-life problem now that deals with iodine-131.